Here's the finding that should reorganize how you think about AI agents. Take a frontier model, hold it completely fixed. Change only the machinery around it, how context is built, how tools are wired, how progress is verified, and long-horizon benchmark scores move by more than a typical model upgrade moves them. The research community now has a name for this, the binding constraint thesis. On hard, long tasks, the harness, not the model, is often driving the outcome. Everyone is arguing about which model is smartest. The variance that decides whether your agent ships is somewhere else entirely. This is the video I've been building toward all year. The certification series taught the model side. The MCP blueprint taught the tool side. Today, the machinery that uses both. And one credential up front, because this channel earns opinions. I build and run an agent harness in production, a multi-agent engineering system with a deterministic core, and the patterns in this video are the ones that survived contact with reality, not framework marketing, anatomy. Let's open it up. Chapter 2, what a harness actually is, and the definition is worth memorizing. The agent harness is the complete software infrastructure wrapping a language model, the orchestration loop, the tools, the memory, the context management, the state persistence, the error handling, and the guardrails. The term was formalized only this year, but the thing existed long before the name. When a major lab describes its coding product, it calls the underlying kit, quote, the agent harness that powers it. The concept has been running your favorite tools all along. The cleanest mental split in the ecosystem. The agent is the emergent behavior, the goal-directed, tool-using, self-correcting entity the user experiences. The harness is the machinery producing that behavior. When someone says, I built an agent, what they actually built is a harness pointed at a model. And the community's one-line job description, which I'd frame on a wall, if you're not the model, you're the harness. Every engineering decision you make around a model, everyone, is harness engineering, whether you've been calling it that or not. The analogy that makes it concrete comes from an essay years ahead of its time. A raw language model is a processor with no memory, no disk, and no input-output, brilliant and inert. The harness is the operating system. It schedules the processor's attention, manages what's in RAM, that's your context window, decides what goes to disk, that's persistent state, and mediates every interaction with the outside world. Nobody ships a bare processor to customers. Nobody ships a bare model either. The question is only whether your operating system is designed or accidental. Chapter 3, the anatomy maps 7 organs, and this diagram is the spine of the whole video. 1. The loop, the heartbeat that runs perceive, decide, act, observe. 2. Planning, how big goals become executable steps. 3. Memory and context, what the model sees and when. 4. Tools, the hands, and you already know the standard there. 5. State, what survives beyond a single context window. 6. Verification and guardrails, how the system knows work is right and safe. 7. Observability and governance, how humans see, audit, and control the whole machine. Every framework you've heard of is a bundle of opinions about these 7. Every production incident is a failure in one of them. 7 chapters follow, 1 per organ, with the arguments that actually matter inside each. Chapter 4, the loop, and let's demystify it immediately. Mechanically, it is often just a while loop. Assemble the prompt, call the model, parse the output, execute any tool calls, feed results back, repeat until done. The famous thought-action observation cycle, the pattern most agents still run at their core, is exactly that loop with good manners. If you can write a while loop and an if statement, you can write an agent loop. The hard part was never the loop. The hard part is everything the loop touches. The production difference is that the loop is bounded, 3 bounds minimum, an iteration ceiling so a confused agent stops instead of spiraling, a budget ceiling, tokens, and money, because an unbounded loop with tool access is a cost incident with extra steps. An explicit stopping criteria, what does done look like, checked by something other than the model's own enthusiasm. The classic long-horizon failure is early stopping. The agent declares victory halfway, and its mirror twin is the infinite polish loop. Both are loop design failures, not intelligence failures, and both are fixed in the harness, with bounds and verification, never with a sterner prompt. See it as code once because seeing kills the mystique. A state object holds the goal, the history, and the budget. While not done and iterations remain and budget remains, build the prompt from state, call the model, parse. If the model called tools, execute them, append the observations. If it produced an answer, run the verifier, and only the verifier may set done to true. That's the entire heartbeat, a dozen lines. Every framework you'll evaluate is this loop, wearing increasingly elaborate clothes. Judge them by the clothes, the state handling, the checkpointing, the verification hooks, because the heartbeat underneath is identical. Chapter 5, Planning, where big goals become steps and the field has converged on a principle worth stating boldly. Plans should be artifacts, not vibes. The weakest planning lives only in the model's context, a paragraph of intentions that degrades as the window fills. The strong pattern externalizes the plan. An explicit task list the agent writes and updates, a milestone file that survives sessions, a dependency graph a supervisor maintains. When the plan is an artifact, it can be inspected, revised, resumed after a crash, and audited after the fact. When it's vibes, it evaporates with the context window. And the frontier of this idea, from the most interesting harness work published this year, the plan can live in executable code. For massive tasks, the orchestrating model writes an actual script that fans work out to dozens or hundreds of parallel sub-agents, with verification between stages. The insight is profound, code as the plan scales beyond any context window, because the plan's state lives in the program, not in the model's attention. A famous demonstration ported a codebase of 750,000 lines this way. You won't need that scale on Tuesday. But the direction, plans moving from prose toward structure toward code, is the direction everything is moving. The honest counterweight, planning has a price and simple tasks don't repay it. A one-tool question doesn't need a decomposition tree. Forcing one adds latency, tokens, and new ways to be wrong. The judgment call, and it is a harness design decision. Below a complexity threshold, act directly. Above it, plan as an artifact, and revise the plan when observations disagree with it. A plan that can't lose an argument with reality is just a slower way to fail. Chapter 6, Memory and the discipline the industry now calls context engineering. 3 tiers to keep straight: working memory, the context window itself, expensive, finite, and the only thing the model actually sees. Episodic memory, what happened, trajectories, past attempts, conversation history, mostly stored outside the window and summarized in. And knowledge memory, durable facts and documents, retrieved on demand. The craft is deciding at every step what earns a place in the window. Not what could be relevant, what earns it. 2 workhorse techniques do most of the real lifting. Compaction. As the window fills, older turns are summarized into a shorter digest, and the digest replaces them, lossy but survivable, and every serious long-horizon system does it. And offloading, intermediate results written to files instead of held in context, the file system as extended memory, with the model holding just the index. The strongest harnesses treat the file system and version control as first-class memory organs. Notes, plans, and state committed like code, surviving crashes and session boundaries for free. And the trade-off this channel already flagged in the MCP Economics chapter, now with its research name: progressive disclosure, loading tool definitions and context as needed instead of front-loading everything, slashes token overhead but charges a planning TAX. An agent that sees only a brief directory can pick the wrong tool or freeze into a dare not choose deadlock because it lacks the detail to commit. The compensation is harness side, semantic routing, a lightweight index that maps intent to the right tool before full definitions load. Cheaper context is not free context. It's context you've moved into routing, and the routing had better exist. Run the earns a place test on a real task, a long refactor across many files. In the window, the plan artifact, the current file, the last few observations, and the failing test output, the things the next decision genuinely needs. In episodic storage, summarized on demand, everything already changed and why. Offloaded to files, every intermediate diff, the full test logs, the exploration notes indexed, not resident. What does not earn a place, the entire code base, the full history, and everything that merely might matter. The window is the scarcest resource in the whole architecture. Spend it like it's your own money, because it is. Chapter 7, Tools, the hands, and this can be the shortest organ chapter in the video because 3 prior videos built it. The standard interface layer is the model context protocol. That's the blueprint series, parts 1 through 3, architecture, building, and security. The number 1 selection lever is the tool description, the third law still undefeated. What this chapter adds is the harness perspective. Tool count discipline, a model choosing among a handful of well-described tools outperforms one drowning in dozens, so curate per task, not per install. Parallelize independent calls, the loop can await several tools at once, and wall clock time is a feature. And route consequential actions through the gate will build in the verification chapter, because hands this capable need a conscience wired in. Chapter 8 state the organ that separates demos from systems. The demo agent lives and dies inside one context window, close the tab and it never existed. The production agent survives, crashes, restarts, session boundaries, even model swaps mid-task. The mechanism is checkpointing, durable snapshots of the plan, the progress, and the working artifacts taken at every meaningful step, so the loop can resume from the last good state instead of from zero. Long horizon continuity isn't a model capability, it's a harness guarantee. The state pattern I'll advocate from production experience, the shared blackboard. Instead of agents whispering to each other in chains of messages, they read and write typed artifacts on a common workspace, a plan artifact, a findings artifact, a decision record, each with a declared shape and a trust level. Any agent can inspect the board, the orchestrator sequences who writes when, and the entire system's knowledge is, at any moment, a set of documents you can open. Debugging becomes reading, auditing becomes reading, resuming becomes reading. The alternative, state smeared across 100 chat messages, is where multi-agent systems go to become unexplainable. And the unglamorous property that saves you at scale, idempotency. Steps will rerun after crashes, after retries, after resumed checkpoints. A step that creates the ticket again on rerun corrupts the world. A step that checks first or writes with a stable key doesn't. Design every consequential step to be safely repeatable, and the whole harness inherits the calm confidence of systems that expect failure. This is ancient distributed systems wisdom, and agents did not repeal it. What a typed artifact looks like in practice, one example. A findings artifact, its identifier, the question it answers, the evidence entries, each with a source, the confidence level, the producing agent, and a trust tier. Is this raw model output, verified output, or human approved? Declared shape so every consumer knows what it's reading. Trust tier so downstream steps can require, only build on verified or better. Two small fields, shape and trust, and suddenly your multi-agent system has something most never get, provenance you can enforce, not just intend. Chapter 9, Verification, the organ that converts optimism into evidence, and the loop upgrade that defines serious harnesses. Plan, execute, verify. The verify step asks, with something other than the model's self-assessment, did that actually work? The gold standard is execution-grounded feedback. Run the tests, run the query, render the page, compare against the expectation. Where execution can't judge, a second model can, a verifier or critic, and the strongest published systems even make verification adversarial, one agent attacking another's work before it merges. The model's confidence is a vibe, the harness's verification is a fact. Guardrails are verification's protective twin, and you've met their logic in the security video. Consequential actions, sending, deleting, paying, deploying, publishing, sit behind gates. Policy checks the harness and forces deterministically, and human approval where stakes warrant it. The trifecta lens carries over whole. An agent with private data, untrusted content, and an outbound channel is one poisoned observation away from exfiltration, so the harness breaks a leg by design. And cost is a guardrail too, per task budgets enforced by the loop, because the most common agent incident in the wild is not a breach, it's a bill. Rank your verifiers because they are not equals. Top of the pyramid, execution, tests pass, the query returns, the build compiles, reality itself votes. Next, deterministic checks, schemas, constraints, invariants, cheap and incorruptible. Then a critic model, useful precisely where judgment is the task and only there. At the bottom, worth almost nothing alone, the working model's self-assessment. The design rule, push every claim as far up this pyramid as it can go, and treat anything resting on self-assessment as unverified by definition. Harnesses fail politely, pyramids fail loudly, choose loudly. Chapter 10, Observability, the organ that makes the other 6 improvable. Minimum viable, every step traced, prompt, response, tool call, result, cost, duration into logs a human can replay. The trajectory, the full path an agent took, is the unit of debugging and the unit of evaluation. From the certification series, the golden set returns, a fixed suite of representative tasks run against every harness change. The binding constraint thesis cuts both ways. If harness changes can beat model upgrades, harness regressions can erase them silently unless you measure. And the practice from my own production system. When a human corrects or rejects an agent's output, capture why, structured, stored, reviewed. That correction stream is the cheapest, most honest evaluation data you will ever own. Governance closes the organ, audit logs of who ran what with which permissions, retention, and cost attribution. Boring, and the difference between a tool and an enterprise system. Chapter 11, Multi-agent and the finding that elevates it from fashion to engineering. Topology is a measurable lever. Recent work shows that choosing the coordination shape, parallel, sequential, hierarchical, or hybrid, based on the task's dependency structure, improves outcomes by double-digit percentages over model selection alone. Read that again. Picking the right shape for the work can matter more than picking a better model. Shapes quickly. Orchestrator and workers. One planner delegates to specialists the default for decomposable work. Parallel fan-out, independent subtasks, simultaneous subagents, verification at the join. Sequential pipeline when each stage feeds the next. And the blackboard from the state chapter. Everyone reads and writes the shared workspace, and coordination happens through artifacts, my production choice, precisely because the state is inspectable. And the warning that keeps this channel honest, multi-agent is the most over-adopted pattern in the field. Every additional agent adds tokens, latency, coordination surface, and new failure modes, subagents duplicating work, contradicting each other, or deadlocking on shared state. The professional sequence is unchanged from the certification series. Single agent with good tools first, add a verifier second, go multi-agent when the task structure, parallelism, or genuine specialization demands it and the measurement proves it. An org chart is not an architecture. Dependencies are. How to actually choose a shape, read the task's dependency graph, not the team's imagination. All subtasks independent, parallel fan-out, verify at the join, and enjoy the wall clock win. Each stage consuming the last one's output, pipeline, and resist the urge to parallelize what has a spine. A mix, some parallel clusters feeding a serial backbone, hierarchical, and orchestrator managing both, and when many perspectives must accumulate on shared evolving state, the blackboard earns its keep, the graph decides. When the graph is a straight line and someone proposes 7 agents, the graph is telling you something about the proposal. Chapter 12, the Determinism Boundary, the design decision I consider the soul of harness engineering, and the one my production system is built around. The principle, everything that must be exactly right belongs in deterministic code, calculators, validators, constraint solvers, schema checks, rule engines. The model's job is what code cannot do. Interpret ambiguity, propose candidates, explain trade-offs, and judge. My system runs a deterministic solver at its core, with language model agents arranged around it, proposing, annotating, and evaluating, never silently overruling. The moment arithmetic, feasibility, or compliance flows through a model instead of through code, you've traded a guarantee for a vibe, and audits notice. The placement test usable on any component. If 2 runs must produce the same answer, it's code. If wrongness must be impossible rather than unlikely, it's code. If the task is interpretation, generation, or judgment under ambiguity, it's the model, wrapped in verification. Draw this boundary explicitly, document it, and defend it in review, because every convenience shortcut that lets the model do the math is a future incident wearing a productivity costume. Neurosymbolic isn't an academic word anymore, it's just what disciplined harnesses look like. One worked example from my own system, genericized, cost roll-ups across a product platform, pure arithmetic over structured data, deterministic code, every run identical, auditable to the cent. The narrative around those numbers, which options look attractive, what trade-offs deserve attention, which risks are underpriced. Model territory, clearly labeled as judgment, never as calculation. The boundary is visible in the interface itself. Numbers carry the solver's signature, prose carries the model's. Reviewers know which is which at a glance. That legibility, more than any single correctness gain, is what the boundary buys, a system whose claims announce their own epistemics. Chapter 13, Failure Modes, Rapid Fire, 6 of them, each with its boring fix, because production knowledge is mostly a catalog of ways things die. Early stopping, the agent declares victory halfway. Fix, verification against explicit completion criteria, never self-report. The infinite loop, same action, no progress. Fix, iteration bounds plus progress detection, is the state actually changing. Context rot, coherence degrades as windows fill and summaries stack. Fix, aggressive compaction, offloading to files and fresh subagents for fresh phases. Goal drift, a long trajectory slowly forgets what it was for. Fix, the plan as a persistent artifact, re-anchored into context at every step. Tool deadlock, progressive disclosure without routing, the agent dare not choose. Fix, the semantic index from the memory chapter. And cost runaway, the agent that works beautifully and bankruptingly. Fix, budgets in the loop, alerts in the observability organ, and a kill switch a human can actually reach. Notice the pattern across all 6, not one fix is a better prompt, every fix is a harness organ doing its job. Chapter 14, Two Lenses, Production Edition. First, your agent completes long tasks impressively in demos, but in real use it announces success with a third of the work missing. First fix. Options, a sterner system prompt demanding thoroughness, upgrade to the newest model, a verification step that checks output against explicit completion criteria before the loop may exit, or double the iteration ceiling. The prompt begs, the model upgrade gambles, the doubled ceiling gives it more time to stop early. The verify step is the fix, early stopping is a loop design failure, and the loop is yours, harness, not model. Second, a team proposes 6 specialized agents for their document pipeline: researcher, extractor, checker, formatter, summarizer, coordinator before shipping anything. Your review says. Options, approve, specialization is best practice. Approve if they add a 7th for security. Start with 1 agent plus a verifier and split only where measured structure, parallelism or true specialization demands it, or reject agents entirely. The 6-agent org chart adds coordination surface with no measured need. The security 7th doubles down on the mistake. Single agent verifier, then split on evidence, the sequence that survives contact with production and with budgets. Chapter 15, Build or Adopt, honestly. The frameworks are real now. Graph-based orchestrators with checkpointing and streaming, full-stack harness kits with planning artifacts, offloading and subagents built in. Adopting one buys you the 7 organs pre-assembled, and that's a fine trade for most teams. Build your own when the determinism boundary is your product, as it is in mine, or when your state model doesn't fit theirs. But whichever you choose, OWN 4 things regardless: your tool descriptions, your verification criteria, your golden set, and your determinism boundary. Those 4 are your product's judgment, and judgment is not something you outsource to a framework default. The honest future question: models keep improving at planning and self-correction, so will harnesses matter less? The field's best answer, and mine: harnesses today do 2 jobs: patching model weaknesses. That job shrinks, and engineering leverage around model intelligence, environments, tools, durable state, verification, and that job compounds. Prompt engineering was supposed to die 3 model generations ago. It just changed shape. The harness will too. The 7 organs will outlive every framework named in this video. That's the anatomy, the loop: planning, memory, tools, state, verification, and observability. 7 organs, the binding constraint, and the determinism boundary that makes it all defensible. Next on this channel, the hands-on companion, running parallel agents on one codebase with worktree isolation, the workflow that's quietly becoming how professionals ship with coding agents. Subscribe and it lands in your feed. If this reorganized how you see agents, the like button is the 30-second thank you. We're building AI up from the ground, one blueprint at a time. I'll see you in the next one.